Hi, Tristan.
Hello.
Tristan is a repeat speaker at Oxidize. He's been speaking at Oxidize 2019. I think it's been easier getting here this time, and I'm very happy to see what Tristan has to say about Rust and Arduinos.
Hello. Yes, so today I'm going to be talking about how I think Rust can be the next Arduino in approximately 5 easy steps, although counting these steps hasn't been done yet, so keep your own count. So I've been a software engineer for 8 years. I have a number of hobby electronics projects on the go. I got my first Arduino as a birthday present back in 2009. It's an original Arduino Mega. And I'm looking to move into Rust full-time, specializing in embedded IoT prototyping. So why should Rust become the next Arduino? So the first thing is to expand the influence of Rust in programming generally. A couple of the questions already have outlined how getting students in at the ground level will increase throughput, increase the usage of Rust in industrial applications. Also increase the chances that newcomers to embedded systems do things correctly. Everyone knows the pitfalls of trying to have a register do 2 things at once, but that's only something you can get with experience. Also decrease the frustration with embedded systems. So Florian tweeted yesterday how all their workshops just worked, and that is definitely a great feature of Rust. I experienced it last year when I was doing the workshop. It's like, wow, this is really simple. So bugs are caught early, which is always good. Any bug that doesn't make it onto the board reduces the chance of going, what the hell is going on here? A lot of things just work. So particularly when you're looking at abstractions and different peripherals, making sure that all those work together is very important. And the perennial example that I come across when I'm using Arduino is Ethernet. Like, there's a lot of Ethernet libraries, and who knows which one actually works for your particular board. And better testing regimes. So we do have cargo test. There were some limitations brought up earlier today about how that might not be ideal, but I'm certain we can sort those out. It's easier to just hack together. You don't really need to know what you're going to be producing before you start. In Reddit, there was a thread about talking about compiler-driven development, and that's very true. I started using Booleans as my type when I don't know what the type is, and the compiler will tell me. And finally, it's a lot easier or a lot better to go from proof of concept to production using Rust. Again, moving to a professional board is perhaps a little bit harder, but from the software point of view, there's actually not that much different, mainly around error handling and dealing with edge cases. So there are 3 important projects in the hobby firmware sector that I want to talk about. Obviously, the first is Arduino. It's very popular. It's used by a lot of beginners. There's a lot of educational resources, courses, trainings, all that jazz. And they do hardware, firmware. They have their own firmware libraries. They have their own IDE. Second is Embed by ARM. So it's developed by ARM. It has educational resources that are more tailored towards the professional side. They too also have their own firmware library, and they have an online IDE, and it is in fact compatible with GCC. So that helps avoid vendor lock-in. And their hardware is done by other companies. So those other companies have the Embed logo on their board. Finally, we have Raspberry Pi. It's primarily a single board computer running Linux on it, and they're more focused on the OS development. They have a lot of educational resources that's devoted a lot to children and younger people. But I included them because they actually have a very interesting company structure, which I'll get to towards the end. So the story of embedded so far in the hobby sort of area, I'm making a very sweeping assumption that embedded Rust is more of an ecosystem rather than just a programming language. There's a lot of evidence to support this, in my experience at least. At the moment, the microcontrollers is generally limited to ARM and RISC-V, although AVR support is actually now in stable. Current guides are good enough for an intermediate user to get going, but would probably struggle for someone completely new to embedded systems. Board support is a bit mixed, and a good experience is defined by which board is chosen. So the DWM 1001, which was used last year, has a pretty good board support crate. Something more like the Atmel's SAMDs are a little bit more limited in their board support. And you sort of need to have a general understanding of what a peripheral is in order to really have a good go at embedded Rust. So first cab off the rank is IDE support. So the preferred IDE for developing Rust probably does need to be free. I know there are some good stuff with the JetBrains IDEs, but when we're talking hobby, it's all about price. So no cost is always going to win out over some. Visual Studio Code is very good, but the GUI can be a little bit tricky to use. You sort of need to understand the command palette and look up terminal support. The Arduino IDE is not actually that very good. It's written in Java. And that has sort of led to some anachronisms, particularly in the error handling. The messages are cryptic at best. Nothing like programming in something C-like and getting a Java error. However, it does have a good library manager for a C or C++ based system. And it does, in fact, have a good board manager. So you just drop down the menu and you can select what board you're programming. So the required improvements on the Rust side. So we need to sort of have board selection support or automatic detection. And from what I understand, ProBRS developing that into sort of fit this niche application is probably a good idea. Adding clear build and program buttons. I haven't written an add-on for Visual Studio Code, but I'm sure with Microsoft support we can add that in. A crate management GUI, nice to have. Many other users of Rust probably want that as well. A good thing I found with the Arduino IDE is serial monitor, particularly when you're using a serial port to program it. Having the serial monitor able to automatically switch between the two is very handy. So memory management. So many base projects include a memory.x file. Having some sort of standardization or automation or GUI for that is pretty important. And also being able to burn on particular bootloaders. So there aren't that many bootloaders in the embedded Rust space yet, but hopefully there will be soon. And being able to build and put that onto the board automatically is a good thing. So on crate support, basically we need more board support crates up to a fairly high level. So a lot of processors have pack and HAL crates. Getting them that extra step to board support is a good thing. There needs to be more higher level traits like the accelerometer crate. There's the things like storage, communications, and other sensors like pressure or humidity or temperature. I'm half thinking of working on the storage crate during the Impl Day, so hit me up if you want to talk about that. A method to transfer Arduino libraries into Rust crates. I've done this a couple times now for my own projects, and while it's not necessarily hard, it's also not that much fun. It involves switching between looking at code and looking at data sheets, which takes a bit of time. And probably one of the bigger things is more examples of using crates and peripherals to build an actual project. So there's a lot of peripherals come with Arduino libraries and have example projects. So we need to be able to expand on that for the embedded Rust side. And it all comes up every now and again, but a mechanism for showing that one particular crate is better than another. At the moment, embedded HAL is the one that everyone goes to, but at some point in time, it may get deprecated or it may become unmaintained. There needs to be a mechanism of some sort to indicate don't use embedded HAL anymore, use embedded HAL 2.0. So I don't have a solution for it. I'm just saying there probably does need to be one. So there are a lot of material, education and training around for Arduino. There's online tutorials, there's YouTube channels, there's books, there's courses. They're made by a wide variety of people for a wide variety of audiences. So from kids to JavaScript developers to people just wanting to try new things. And they're made by a wide variety of, and the difference in quality is actually a pretty good thing. It means that there's lots of variety for everyone to use, and if one particular guide goes into too much detail for one particular person, well, then there's probably another guide that's a little bit higher up and bit less detailed, but a lot easier to follow. And again, a lot of peripherals have examples and guides about them. So we need to be making our own guides for this and trying to replicate this in embedded Rust. So we also need to be able to market embedded Rust. So Arduino has a very catchy and versatile name. I suspect any Italian speakers probably hate the Duino suffix that is used everywhere. So a full set of marketing collateral is going to be needed, including logos, style guides, all that stuff. And we also need to do a bit of research about what markets we want to target specifically within the hobby area. Are we looking more at the established ones, or are we looking at complete newcomers? And we also, when it comes time, we also need to launch the brand to various blogs and other content creators. So basically getting it out there that, yep, embedded Rust is now very, very much should be used in the hobby area. So I have a little bit of a suggestion for a name, Oxidize. There are a couple of reasons for this. It's already associated with embedded Rust. It's actually a pretty good name in and of itself, and it's workable as a product family name. A lot of the collateral that would need to be created actually already exists. But if for some reason, if we don't want to choose that, something else. I'm certainly not wedded to this idea. It's and we do obviously need to talk to Fairer Systems about that since they have all that detail. So next up is hardware, because obviously Arduino is as much a hardware company as a software one. So if we do decide to develop hardware, then it needs to become Tier 1 supported. You can't really sell something without having the full support of the compiler. It will need a comprehensive board support crate with examples and training resources. And price is probably around $25 to $45 depending on what peripherals are included. Things like wireless communications, it's a nice to have, but it's not critical yet. And if we do decide to include communications, then a fairly complete and comprehensive wireless stack is going to be needed that actually implements that. So if it is perfectly reasonable to outsource this to an existing supplier like SparkFun or Adafruit. but the branding does need to be clear. So it needs to be like embedded Rust on Spark Fun Artemis or something like that. So obviously the Artemis, the Feather, and the Tinsys, they all have different ideas about what makes a good development board. Tinsy is definitely raw processing power, whereas Feather is perhaps a little bit more on the prototyping side. And I guess any sort of hardware will need a strong backing to deal with that. So the big elephant in the room, of course, is AVR support. So Arduino started out with AVR, but they are transitioning to ARM. The last AVR board that they've made is about 2013, which is actually 7 years ago. A lot of the cheap clones use AVR. So going back to the board price of $25 US, an AVR clone can be had for less than $2. So that's a very big price difference to be made up. So AVR now has tier 3 Rust support. So that may be enough. Having our own board for embedded Rust would mitigate that issue a fair amount. It's like we can say this is the best board to use. You can use an AVR board, but it's not going to be as good. I guess my main takeaway is that we need to manage expectations in this respect. We can't, if we're not going to boost up AVR to tier 2, then we need to say, yeah, you can use it, you can try it, but it's definitely not guaranteed to work. So everything together, a lot of these things will actually probably happen independently of any push from the embedded side of Rust. So the IDE and tooling stuff is a lot of that will probably happen naturally without too much effort. The guides and tutorials might require a bit of encouragement, get people out there writing guides, making their own courses, using proof rules and writing up their own blog. The marketing and branding can sort of start out simple and ramp up sort of once that path is decided upon. So we don't need to go everything all at once. Hardware development is obviously a lot harder to do and needs a formal structure to succeed. So there's design, manufacturer, distribution, specific software support, and lots of guides and examples to deal with that. So making sure that training exists for all that stuff, which obviously means that there needs to be some formal company running this. So, which brings me to the Rust Foundation. So the Raspberry Pi Foundation exists to promote the usage of computing around the world and training up people in that. And Raspberry Pi Inc. basically develops and sells Raspberry Pi boards to both enable and fund the Foundation's goals. There is currently talk. I'm not privy to how advanced that is. But the talk that I've seen is that a Rust Foundation is probably going to be sort of similar in that it's going to be fairly lightweight up the top and more of an organizational tool. So having a embedded Rust board Inc. company under that and owned by the Foundation gives the Foundation a bit of flexibility and importantly gives it a small income stream. So having that passive income and ensuring that Rust can continue to be developed and supported well into the future. Obviously, this is going to take a lot more discussion to sort out, and certainly willing to help where I can. So in conclusion, implementing all these ideas gives Rust sort of the best chance of becoming the next Arduino, but even then it's still hard. Arduino is spending a lot of resources at becoming more professional. They're building a new IDE, they have new professional boards, they're developing their own IoT systems. So bringing Rust up to that level is hard, and particularly when you have a brand name such as strong as Arduino. Perhaps something more like the embed level where we're just organizing everything making a one-stop shop, saying you want to learn embedded Rust, here's where you go. These are the boards you want. So we don't need a board made to fulfill that level, as we can just use the existing boards or further develop the existing boards as required. So which path to take? I can't answer that question. It's like everything in Rust, it's going to be decided upon by the community. Hopefully I can help facilitate discussion or give my opinions about what I think is best. So I'm started my own company, Lost Consulting, that's working on embedded IoT solutions. So we'll have a little bit of capacity to help assist any development required. And you can contact me either on Twitter or on website, and I'm going to be in the chat for a couple more hours today and early tomorrow, my time. And that's it.
Yeah, thanks for this talk. I can report from the chat that there's no questions, only already engaged conversation. So I can highly recommend you to hop over there. I've been running conference for quite long, and this has been the first time someone applied for the conference brand on stream. Quite happy. Yeah, thank you for your talk. I think it was laid out a good vision, and it's always pleasing to see people talk about, especially about foundations, in such a good manner with a lot of insight. Thank you.
Thank you.